This is the lesson for reviewing Chapter 4, Sections 6 and 7, which is writing linear equations in slope-intercept form. So let's take a look at the first type of problem we'll end up seeing, and this one says use point slope. Use point slope to write an equation for a line that passes through a given point and has the given slope. And so we'll take a look at our first part here. And so on this first equation, it says m equals negative 2/3. So that's our slope. This is our point, and this point is 3 spaces to the right, 2 spaces up. So what I'm going to end up doing is using point slope, which goes this way. Y minus y1 equals m times x minus x1. And I'm taking the point and putting it in place of y1 and x1. So it should be y minus 2 equals the slope of negative 2/3 times by x minus, and then the y value, which is, or the x value, which is 3. And so I distribute, and I still have that y minus 2 equals negative 2/3 x, and then here the 3 goes into 3 one time. I multiply across, watch the signs there, negative 1 and negative 2 make a positive 2. And then all I have to do is add the 2 to all sides, and I get the answer. So y equals negative 2/3 x plus 4, and that's the equation. And you can see that with the graph. If I end up using that slope, I could go down 2 over 3, or I could go up 2 over 3 to the left. And you can see how it crosses right there at positive 4, and that's what the y-intercept is, sloping the negative 2/3. So on this next one, this point is negative 2, 0. So I'm going to use that point in point slope. So y minus y1 equals m times by x minus x1. So I substitute in, I've got y minus 0 equals the slope of 5/2 times by x minus negative 2. So that minus negative, anytime you have to substitute in a negative component into a point, you're going to end up adding, because you'll end up adding the opposite. And so here I have y minus 0, which is just 0, and then I just have to distribute here. So 5/2 x plus 5. I got 5 because 2 goes into 2 one time, multiplying across. 1 times 5 makes 5. So let's take a look at another set of directions. It says write in slope-intercept form an equation of a line that passes through the given points. So here we don't have the slope, so we first have to find the slope. So we're going to use the slope formula, y minus y1 over x minus x1. So I'll take the two values. I'm going to take the 2 and subtract the 1. Those are my y values. And so I'm going to do 2 minus 1. Now down below, I'm going to subtract the x values, x minus x1. And so that's going to be 8 minus 4. So I do the work, I get 1 over 4. So 1/4, that's the slope. So now pick a point. Pick either point. It doesn't matter which point you pick. Either point. And use the slope in point slope. So we're going to use this formula, y minus y1 equals m times x minus x1. And so it doesn't matter which point you pick. I'm going to pick this point. I'll use 4, 1. So I substitute in, I've got y minus 1 equals the slope of 1/4 times by x minus 4. So I go ahead and distribute, and I've got y minus 1 equals 1/4 x minus 1. So I got that because 4 goes into 4 one time. Multiplying across leaves me with 1. So all I have to do is add the 1 to all sides, and I get the answer. Y equals 1/4 x. You could write down 1/4 x plus 0, or you could just write down y equals 1/4 x, because the ones end up canceling out. Either answer is fine. So on this next one, we end up doing the same thing. We have to find the slope. So 7 minus 3, those are the y values. 7 minus 3 over the x values are going to end up being 2 minus negative 2. So minus negative makes it plus positive. So I'll add the opposite there, and so I end up with 4 over 4. So that just makes 1 as the slope. And so again, you pick either point. I'll use the negative 2 comma 3 this time. So I substitute into point slope. So y minus 3 equals, and then m, which is 1, times by x minus negative 2. So again, you put in that minus negative, you'll see right away that's going to end up making a plus positive. So when you go ahead and finish off the work, we've got y minus 3 equals, and then this just makes x plus 2, because 1 times x and 1 times 2 just gives me those same values. So then you just have to add the 3 to all sides, and you get your equation. Y equals x plus 5. So looking at our next problem, it's this parasailing problem, and it says that you finish parasailing and are being pulled back. Pulled back. Okay, so that tells us something about what's going on. Okay, so after 2 seconds, you are 25 feet above the water. Write an equation to represent the situation. So right here, so notice that you're being pulled back, so that tells me that I'm going to end up having a negative rate, or negative slope. And so my slope is right here. This represents the rate of change. And the rate of change is my slope. And so I'm going to use m as negative 10. So I've got an equation that looks like this. I'm going to go y minus y1 equals m times x minus x1, the point slope formula. I know what m is. M's negative 10. I just need a point. Well, this gives it to me right here. 2 seconds, 25 feet above the water. So our x value and y value is what I want, a point, an ordered pair. X is in seconds. It's in seconds because it tells us right here, x is in seconds, and y is in feet. And so that helps us figure out how to write the ordered pair. I could also get that from the slope. Notice the slope is feet per second. Y to x. Rate of change is always rise over run. So y is x, or y is feet, x is seconds. So that tells me that I've got my 2 seconds is the x component, 25 feet above the water is the y component from right here. So now I can substitute in. I've got y minus y1, which is 25, equals the slope, which is negative 10, times by x minus 2. So I go ahead and distribute, and I've got y minus 25 equals negative 10x plus 20. So I add the 25 to all sides, and that tells me something. It tells me what the y-intercept is. So y equals negative 10x. This is how fast we're being pulled down, 10 feet per second. And I have a 45 as the y-intercept. So let's see what it says. It says here that we're supposed to write and graph an equation. So I'll sketch a quick coordinate plane. And all I need is the first quadrant. So here's my y or x-axis represents the number of seconds, and I have the y-axis represents the height above boat, and this is in feet. And so I know that I started 45 feet above the water right there. There's 45. And then I decrease by 10 feet per second. And eventually, I end up being right back on the boat. And so that's going to end up taking, and we'll find out how much time that takes. See, if I put 0, 0 is right here, where I end up 0 feet above the boat, so back in the boat here. And if I go ahead and solve for x, I'd end up adding 10x to both sides, and that would give me 10x equals 45. So then when I divide, x would be 4.5. So that's 4.5 seconds it's going to take us to get back into the boat. So this will end up being 4.5 seconds there. So that's what the graph would end up looking like. So it does ask me also for this other part right here. And so it says, at what height are you parasailing? Well, what height am I parasailing? It's the y-intercept. 45, I am parasailing, we'll say, parasailing at 45 feet above the boat. And the reason I know that is because I'll say which is the y-intercept. So 45 feet is what I started at before I was being pulled back into the boat. And so that's how I know it's the height at which I was parasailing. So those are the types of problems you'll see on tonight's homework. Good luck.